example 3, find the degree measure of theta in the following. We're finding inverse tangent of 1, okay? Inverse tangent of 1. And so you've always got two things, what and where. If we look at the chart, okay? Look in the chart for where tangent is going to give you 1. Remember, tangent is sine over cosine, so sine over cosine. We're trying to get 1, so I'm looking at the square root of 2 over 2 divided by itself. Okay? So that would be pi over 4 or 45. Okay? That's a 45. Since we're in degrees, that's a 45. All right? So that's what you want to do. It's kind of subtle, but you always want to remember the domain and the range. Domain for inverse tangents is, I believe that's all real numbers. So that means you can plug in anything you want. The range is from negative pi over 2 to positive pi over 2. To me, the way I look at this is I'm allowed to have a negative answer. Okay? If I'm allowed to have a negative answer, maybe that makes it easier. I don't have to think quite as much. But I know this means from negative pi over 2 down here to positive pi over 2 up here. Okay? That's quadrants 1 and 4. Okay? Or if we're in degrees, that's from negative 90 degrees to positive 90 degrees. Okay, negative 90 is down here, positive 90 is up here. We're in the first and fourth quadrant. Okay? But I don't really need all that stuff. The fact that this number 1 was positive tells me that I have to be located in quadrant 1. I know that that means quadrant 1. So when you think about the what and the where, okay, that 45 degrees in quadrant 1, 45 degrees in quadrant 1 just is what it is. This answer is 45. Okay? This answer is 45. So let's think about what it would have been if I had done inverse tangent of, let's do like square root of 3. Okay? Square root of 3. So when you look in the chart, square root of 3 is coming from this. Square root of 3 over 2 over 1/2. Those 2's cancel out, and you get the square root of 3. And so you're looking at 60 degrees, right? 60 degrees, okay? And so if that's a positive square root of 3, then that tells me that this is in quadrant 1. And 60 degrees is just 60 degrees, okay? However, if that was a negative, if I had said like tangent, inverse tangent of negative square root of 3, you're still looking at your 60 degree reference, but that negative right there tells you that it's in quadrant 4. Quadrant 4, because that's where we're defined over here. Quadrants 1 and 4, but when we're negative, we're in quadrant 4. Okay? And so the way I look at it is I'm allowed to have a negative answer. If I'm allowed to have a negative answer, then you can just stick a negative in front, and the answer is negative 60 degrees. That won't always be the case. Okay? But with this one, since it's defined from negative pi over 2 to positive pi over 2, or from negative 90 to positive 90, that's the case. All right. So part B, I'm looking at inverse secant of 2. Of course, we don't have that in our chart. It's hard to do the reciprocal functions like secant, cosecant, and cotangent. And so what we would do is look at the reciprocal function. Secant is the reciprocal of cosine. So let's try inverse cosine of 1/2. You take the reciprocal. The reciprocal of secant is cosine, and the reciprocal of 2 is 1/2. And so I'm looking at secant, and so what's the domain and the range of secant, or inverse secant rather? The domain is this weird from negative infinity to negative 1 union with 1 to positive infinity. And what that means is anything else besides what's in between negative 1 and 1. Okay, it can't be between negative 1 and 1. It has to be outside of that. And so that means that my 2 right here is okay. That's fine. I'm allowed to plug in a 2. That's the domain. The range for inverse secant is from 0 to pi. Or in this case, from 0 to 180 degrees. Okay? And so you look at that, and 0 to pi is talking about quadrants 1 and 2. And if it's positive, we'd be in quadrant 1, and if it's negative, we put it in quadrant 2. And so you look at the inverse cosine of 1/2, and we just look at the chart. Inverse cosine, there's 1/2, it goes to a 60-degree angle, right? 60-degree angle. So that's the what that I get from the chart. But the fact that this was a positive number tells me that I'm in the first quadrant. Okay? It's 60 degrees in that first quadrant. Okay? It's 60 degrees in that first quadrant. And so it just is what it is. It's 60 degrees. Okay? Now, if that had been inverse secant of -2, and we did the reciprocal function inverse cosine of -1/2, that's going to be a little bit different. Okay? That's going to be your 60-degree reference angle. Okay? The what is still the same. You're still getting that 60 degrees from the chart. But since this is defined in quadrants 1 and 2, that negative value tells me that I'm in quadrant 2. I know I'm in quadrant 2. And so what that's going to require is to put a 60-degree reference in quadrant 2. And that's not -60. That's not -60. That's 60 degrees before you get to 180. That's 120 degrees. So you're going to have to be careful on some of these